We are basically the public works department for the University of Oregon. So like any public works department, we keep the buildings up, we make sure things are in good repair, we keep the water inside the pipes rather than outside, we keep the roofs from leaking too much, and we do everything that's needed to maintain the grounds and the physical environment of the campus to make sure it does a very good job for the people who are visiting or researching or actually performing studies at the University of Oregon. Our first building was built in 1876, and that would be Dede Hall. And in those days, of course, there was no one even envisioning that we would someday have 25,000 students. So the first heating systems on campus were fireplaces in Dede Hall. And so when the 1924 plant was built, that was on the other side of Franklin Boulevard in an area that at the time was probably seen as one of the largest areas that the campus would ever encompass. But of course, as time has gone on, the campus has grown, and so in the 50s, students coming back from World War II flooded the campus. All kinds of GIs wanting to take advantage of the new education bills, and so our campus population soared again. And at that time, the central power plant, as it was called, which was near Lawrence Hall, was moved to the other side of Franklin Boulevard, where it is now. So a plant was built that integrated both a heating plant, a cooling plant, and a large number of tunnels that go throughout the campus. In fact, many people are surprised to learn that there's over 3.5, almost 4 miles of tunnels underneath campus. And so in addition to having the heat generating systems like steam and electricity, we also have this distribution system that was put in beginning in the 20s. And this has made it much easier for us to maintain the distribution system, to work on underground utilities, sewer lines, domestic water lines, and all kinds of different ways to transport our steam and chilled water now to campus. Now, in the 2011 time, we're looking at Central Power Plant Model 4. The first being the original fireplaces in Dede, the second being the Lawrence Hall 1924 plant, the third being the old 1948 plant, and the fourth being the 2011 plant that's taking shape right now, located on the same footprint but using completely different fuels, different cooling methods, much more highly efficient and much less of a pollution problem than any of the other fuels we've had before. Chilled water is very important because some of our devices that we have now generate so much spare heat that it would heat up the building very quickly if we didn't find a way to move it out. And for many years, up until last year as a matter of fact, all the cooling that took place on the campus came as a result of us moving the heat, the excess heat from campus, and moving it into the mill race. As still more environmental rules would come into play, the concern was that we were, in a sense, polluting the Willamette River with heat from the campus. So the decision was made to try to improve our environmental standing by using a conventional cooling system, air cooling system, and cooling towers, which were constructed and finished really in the fall of 2010.
We just recently built a $33 million brand new chilled water plant and building.
We were getting to so much problem and headache and difficulties as far as maintenance, repair, and cost. And this new equipment would just give us the better efficient and clean system.
The chilled water is produced at the chiller plant and is sent through a series of tunnels to all the buildings on campus.
The individual buildings bring that water in, and through heat exchange process they transfer the heat from their building into that water and send it back to us as slightly warmer but still cool. You wouldn't want to take a bath in 54-degree water that comes back from campus to be recooled down to 42 again.
We had 4 existing chillers that served the campus that were undersized, and so we needed more capacity as the campus was growing.
It was just time, basically, for an upgrade, sort of similar to what I remember from old Star Trek episodes where I think we can hold it, Scotty, and we were holding it, but it would be much better to get the better equipment and the more efficient equipment and reliable equipment, because equipment in general, just like a lot of other things in life, only has a certain lifespan, and so we were coming to the end of that.
And again, we looked at what the campus would need based on the planning and master plan model for the next 50 years, and made sure that we had enough capacity and room to build out what was needed in the next 50 years, but only currently put in what was required for the next 15 years.
The steam is used throughout the campus for heating, but for a number of other purposes too. Steam is used for sterilizing petri dishes and other research items. It's used for cage cleaning. Steam is also used for cooking in the various dormitories.
We bring water into our boilers, and inside those boilers we heat it up until it flashes into steam, and then that steam is utilized somewhere out in the plant, either directly at the pressure we generate it at, or we reduce its pressure and send it out to campus. And then the campus has heat exchangers which capture the heat out of that steam to heat the buildings. And in capturing that heat, they then condense the steam into water, which we call condensate.
And we make sure that we get plenty of condensate water returned back to us that would goes back to our system. And condensate is 140 degrees, 150 degrees temperature. That's a lot of saving the energy in there.
We had 2 older boilers in there and 1 very large boiler that was converted from burning wood to burning natural gas. It was very inefficient. Again, the campus was growing and we needed more efficient systems and more capacity.
I think it's obvious that you want things to be more efficient because it is better in terms of the planet. We're not using as many resources. It's better in terms of cost.
We had the old equipment that it would not be able to supply the demand, campus demand, and constantly needed to spend money on because it was too old. And then it was time to upgrade the system, time to upgrade with something is more efficient.
We renovated 1 existing boiler that produces steam that is sent to campus, added a 2nd boiler, and we're in the process of putting in a cogeneration facility that will not only produce steam but also produce electricity. The upgrade of the central plant, as we got into the design of it, we discovered that the university had grown beyond what the utility could provide us in the type of utility distribution system that was currently serving the campus. So then the decision was made to go with a substation rather than expanding the existing grid system that was serving the campus.
We switched from E-Web distribution to Bonneville transmission. That was August of this year, 18th and 19th. Totally, it's 100% more efficient.
And that is fed all the way back from the Bonneville Power Administration dams. So it takes something fairly catastrophic in order to have the university lose any sort of power.
Multiple times in the past, there's been failures where a bird crosses 2 power lines and shorts it out, and we experience a couple of hours worth of shutdown.
The outage possibility has lessened considerable. Once we bring in our own cogen, we could even probably lessen it some more.
The electric power, of course, is used for everything: lighting, turning fans, running scientific equipment, running computers, running everything that might be expected in a modern research institution such as we have right now.
The planning behind this was to build out for a 30 to 40 year plan on build out. So in other words, our capacity here is more than sufficient for what we have on campus right now. But with the buildings that could come online or on the future, we will have enough to where we should be able to sustain what we have here right now without any further addition for 30 to 40 years of campus life here. New buildings, new science buildings, new dorms, whatever they could come up with. This cost somewhere around $10 million to put this substation in. So instead of spending, you know, $10 million on just what we needed for right now, we went the extra mile to make sure it was done proper and right, and with the expansion.
We have every reason to believe that we'll get away from a lot of the power failures that we've experienced in the recent past, where we have power outages at times that last for an hour or two at a time. And we're going to get into a system via relays and controls and that more reliable distribution network to where we should expect only momentary outages, if even those.